have a office park. In this office park that we are working in this, for example, office park, we have two or maybe more than two buildings. Okay, all of them are on the ownership and of the, for example, one company. In this office park we have two buildings, building 1 and also building 2. Okay, in each building we have the network, the LAN, okay, including one distribution layer switch and also multiple access layer switch. Now we want to connect these two, for example, building to each other, these two networks of the buildings to each other. The one method is using the higher level, for example, core switch. Okay, with this core switch we can connect the different networks in the, for example, multiple buildings together. Because of that, now we have a 3 level of the hierarchy. The name of this 3rd level is the core layer. Okay, core layer is the layer higher than the distribution layer. In the core layer we are aggregating traffic of distribution switch in very large campus LANs. Here we have a campus. Okay, what is the campus? Let me to give you one definition. This is a campus LAN. You know about the definition of the LAN. What is the LAN? LAN, or local area network, is a network with the residing in a small area, for example, in one building. Okay, this is one LAN, this is another LAN. When you have you are using multiple LANs near each other and you are connecting these multiple LANs, for example, in one office park, and connect them to each other, now we have a campus LAN. Okay, or maybe in some references you can see the term of CAN or campus LAN. Okay, this is a large LAN, not anymore. After that, you know that here now we have the core layer. The core layer should aggregate the traffic of distribution switch in very large campus LANs, providing very high forwarding rate for the larger volume of traffic due to the size of the network. You know it. You know that with the only function of the core switch is not connecting the distribution switch and maybe the all of the network together. Why? Look at here. In most cases we are connecting all of the WAN connections to the router. Assume that here we have a router. This router is a router that we are using it for the connecting to the for example, internet. Okay, because of that this router should connect to the core switch. Okay, and after that now we can configure this router to connect to the ISP's router, and after that we can receive the internet from the this router, the edge router, and after that all of the computers in the LAN, okay, can connect from the core switch to the router, edge router, and then to the ISP. Also, maybe you are using the other routers for connecting the campus LAN. This is the campus LAN to the other branches. You know that in each company we have some branches in some other places, another city, another country. Okay, because of that, for these routers, okay, again we should connect them to the campus core switch. Okay, and here now we have for example the WAN of the branches. Actually the core switch is the central point for connecting, for sending traffic between all of the access switches in multiple buildings, and also to the internet and also to the WAN. Because of that we call it the core switch, and the most functionality of the core switch is the high forwarding throughput. Okay, because of that now we know that in some larger campus we need to use the 3-tier or 3 level of design. You know that in the first days we had used only the 2-tier design, but now you can see that we are experiencing the 3-tier campus design. Let me to write here. Here now we have a 3-tier campus design. Okay, but here we can see a 2-tier campus design. Both of them can be experienced in today's networks. In smaller networks, smaller LANs, we are using the 2-tier campus design. In the larger campus, we are using the 3-tier campus design. Okay, this is the function of the 2-tier and also 3-tier networks. But let me to give you a little more information about for example, design of one LAN. In this picture, you can see three buildings, the building 1, building 2, and building 3, as you can see. And in each building, we have, for example, 1 or 2 distribution layer switch. This is the distribution layer 1, distribution 2. And here it means D11 means distribution of the building 1. And this is the first distribution, D12, distribution of the switch in the building 1 and the second switch. A11 means access in building 1, and this is the first access, second access, third access, and also fourth access. The question is that how we can connect these three buildings in one campus LAN to each other. You know that here actually we have one office park, one campus. In this campus we have a three building, and in each building we have a switch block. Okay, this is the one switch block. What is the switch block? Let me to give you definition. For combination of the switch and the distribution switch and also access layer switch, we have a term, we call it switch block. Actually, we are connecting the switch blocks together. How many, for example, way is available for connecting different switch blocks to each other, multiple switch block to each other? For example, here we have 3 switch block, and we want to connect these 3 switch block to each other. In a smaller numbers of the switch block, for example, 2 switch block or 3 switch blocks, and also with the limited number, limited volume of the traffic, we can connect directly these switch blocks to each other. Here you can see one mesh topology. Okay, why? Because the D11 now is connected to all of the other distribution layer switch, again D12 to all of the other distribution switch, and also other distribution layer switch. Okay, because of that, here we can see between the switch blocks, okay, we are using the full mesh topology. This is the full mesh. Okay, and you know that for full mesh we need multiple interface and also multiple links. You know that we have a formula, n multiply n minus 1, n is the number of the distribution layer switch, divided to 2 is the required, for example, connection. For example, here we have 6 switch block, 6 distribution layer switch, 6 multiply 5 divided to 2 equal to 15. We need to have 15 links between for example, switch blocks, and this means that only for smaller networks we can use this method. This is the collapsed core. Okay, this is the collapsed core of design for connecting the different switch blocks to each other, and only we are using the collapsed core when we have a lower number of the buildings, and also for example when we don't have many traffic between the switch blocks or between the buildings. Okay, why we should call it the collapsed core? Because here you don't use for example third layer. You know that here we are using the 2-layer hierarchy, distribution access, distribution access, distribution access. We don't have the 3-layer. Here we are using a 2-layer approach for connecting different buildings together, and because of that, this is the collapse core. We don't have a real core. We are using the collapse core. This is like a collapse core. Let me to show you the next available design for connecting multiple buildings to each other. We call it the a dual core, or maybe the 3-tier building design. Here you can see that we are using a 3-tier, not the collapse core. This is the 3, okay, a tier design, or 3-tier building design. For example, let me to write here building design. And in other term, we can call it the, for example, dual core design or core design. Okay, why? Because here you can see that we are using the core layer, the 3rd layer. Here we have building 1, building 2, building 3. We are using another level, the core. With the core, we can connect the different, for example, switch blocks to each other, or different buildings to each other. In this method, we have more flexibility, and also we can forward more volume of the traffic. The reason is that you know that in core switch we have multiple interfaces, maybe more than 100, 200, 500 interfaces, and because of that, and also we have high throughput rate in the core switch. You can easily extend the for example, the 3 building blocks to 3 building network or 3 switch block to, for example, 10 building and 10 switch block. Okay, because of that, when you are using more than 3 or 4 building networks, you want to connect them